Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on atomic weight and how to calculate it. So let's get started. So the atomic weight is the weight of the element that is given on the periodic table. It is the average mass of all of the isotopes of that element. So to find atomic weight, we use this formula. We take the mass of the isotope, multiply it by its abundance, divide by 100, and then do that for every single isotope and then add all of those values together. All right, so if we look at this first example here, it says the boron 10 isotope has an abundance of 19.9%. Boron 11 isotope has an abundance of 80.1%. Calculate the atomic weight of boron. Okay, so we have two isotopes of boron, the boron 10 and the boron 11. So those are our masses. So the boron 10 isotope has a mass of 10. The boron 11 isotope has a mass of 11. The boron 10 isotope has an abundance of 19.9%, so that is my A1, and the number 2 isotope has an abundance of 80.1%, so that is my A2. So then I just plug it into my formula. So the atomic weight is going to be the mass times abundance of isotope 1 divided by 100, plus the mass times the abundance of isotope 2 divided by 100. Right? So there's several different ways that you can put this into your calculator. You can do it just as shown here with all the parentheses. So we can do 10 times 19.9 divided by 100, close parentheses, plus 11 times 80.1 divided by 100, close parentheses. And we get an answer. Or if you don't want to keep dividing by 100, you can do all the multiplication and addition and then go back and divide by 100 at the end. So I can do 10 times 19.9, close parentheses, plus 11 times 80.1, close parentheses, and then take that and divide it by 100, and I still get the same answer. If you're going to do it this way, you have to make sure that you do the divide by 100 in a second step, because if you just do this, you get a very, very different answer. All right. Okay, so our answer here is 10.801. For atomic weight, we're just going to round to 2 decimal places because the atomic weights on our periodic table are rounded to 2 decimal places. And the unit that we use is the unit of AMU. So this is going to be 10.80 AMU. So, straightforward enough. Okay, so if we look at these next examples, we'll notice that it doesn't tell us what element we have. So if you're asked to find atomic weight, there's nothing to stop you from finding the element on the periodic table and then just recording that atomic weight because that is what we are calculating. So instead of being given an element, we're just given the isotopes and abundances, and then we have to figure out what that element is based on its atomic weight. So we do this in the same way. Here we're given the mass and abundance, the mass and abundance, mass, abundance, mass, abundance. So we have 4 isotopes, so we're going to need to do 4 sets of parentheses to find the atomic weight. So the atomic weight is going to be equal to, the first isotope is 20.4, and its abundance is 1.40, divide by 100, plus 206 times 24.10 over 100, plus 207 times 22.10 divided by 100, plus 208 times 52.40 divided by 100. All right, so that's all my isotopes. So again, I'm just going to plug all of this into my calculator, and the atomic weight that I get is going to be 207.24 AMU. All right, so now to identify the element, I'm going to go to the periodic table and find the element that has an atomic mass of 207.24. All right, so here I have my periodic table. The atomic weights are mostly in numerical order, so I have here 130, 190, 207. So lead has an atomic weight of 207.2, which is essentially 207.24. Thallium is 204 and bismuth is 208, so those are not correct. So lead is my element. Pb, which is lead. All right, let's do another. Here again, we're given isotope data. In this particular case, instead of being given mass number, we're given these exact mass values. So it turns out that the mass number of an element isn't the exact mass because protons and neutrons masses are slightly greater than 1. So we have these values that are here instead. But it doesn't make any difference. We just take the whole mass that's given, multiply by abundance, divide by 100. So it's just more numbers we're putting into the calculator, essentially, but we're doing the same thing. So atomic weight is going to be 57.935 times 68.08 divide by 100. All right, and I'm going to do this for all of them. That's the second one. That's the third one. That's the fourth one. And that's the fifth one. All right, so again, I plug all of that into my calculator, and the answer that I get here is 58.69 AMU. All right, so let's go to our periodic table, and 58.69 is exactly nickel. 58.93 is close, but 58.69 is right on the target, so that is going to be our element. So Ni is nickel. All right, let's do one more. Here it says element X exists in nature's two isotopes with masses of 151 and 153. The 151 isotope has an abundance of 51.28. What's the atomic weight? All right, so this one's a little bit different because while we're given both masses, I'm given 151 and 153, I only have the abundance of the 151 isotope. But what we do know here is that abundance always has to equal 100%. So if I take 100 minus 58.28, I get 48.72%, and that's going to be the abundance for the second isotope here, 48.72%. All right, and then now I have all the information I need to find atomic weight. So I do mass times abundance of the first isotope plus the mass times abundance of the second isotope, and I get 151.97 AMU. So I'm going to go to my periodic table now, and I'm going to find the element with a mass of 151. This is 37 and this is 174, so that means that's down here somewhere, and here it is. 151.97 is going to be europium. U is europium. Europium. All right, so that is how we find atomic weight. This has been another episode of Chemistry with Wikipedia Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.